In this video, we're going to combine our knowledge of parabolas and quadratic relations and their different forms with application questions. And in all of these application questions, you will be given the equation. You won't have to come up with one on your own. That is for another time. So let's get started. The height h in meters of a football t seconds after Brady throws it is described by h equals negative 5t squared plus 20t plus 25. So this is a projectile type of question. Now, the first part says, from what height does Brady throw the football? So maybe we want to do a little sketch so that way as we read the questions, we know what key property we're being asked for. And remember, they can ask you for a y-intercept, the zeros, the vertex, or just a random point on the parabola. So I know my two variables are time on the x-axis and height on the y-axis. I already know this is in standard form. My parabola opens down because of that negative 5, and I know what my y-intercept is, so I know I'm not going to begin at the origin. So this is just a rough sketch for myself. Now, because it asks from what height does Brady throw the football, start or beginning should tell you about the y-intercept. And the y-intercept is 25. And we do have to include units, which would be meters. So maybe you want to make a little note that that is your y-intercept. So anytime you see the word initial height or starting height or beginning, that should be your clue that you are asked for the y-intercept. Next, after how many seconds does the ball land? The ball lands right over here, and that is an x-intercept or a 0. So in this scenario, they are asking us for the 0 or when the height is equal to 0. So I'm going to set my equation equal to 0 because I know that is the proper form of solving for my x-intercepts, plus ground level is a height of 0. Now I have created a quadratic equation for myself that I need to solve. And we should remember that to solve a quadratic relation or to solve for the zeros, we have to factor. So the first thing I notice is that there's a common factor of negative 5. So I'm going to factor that out, and I'm going to be very careful with my signs. So 20t divided by negative 5 will be negative 4t. 25 divided by negative 5 is negative 5. Now I have a simple trinomial in my brackets. So I'm looking for two numbers that multiply to negative 5 and add up to negative 4. So that would be negative 5 and positive 1. And from this, I would set my brackets equal to 0, and I will solve for t. So t equals 5, or t equals negative 1. Now negative 1 does not make sense because the ball did not land negative 1 seconds ago. So 5 would be your answer, and that would be the x-intercept. So therefore, the ball lands after 5 seconds. And you do need a therefore statement. So in this scenario, the clue that you're looking for the x-intercepts is the word landing. Okay, how long is the ball over a height of 40 meters? A height of 40 meters means h equals 40. So we're going to set our equation equal to 40, and then again, we have a quadratic equation we have to solve. Now, visually, let's say 40 meters is right here. If I draw a dotted line, I can see that there are 2 points when the height is 40, but I want to know how long the ball is above 40. So we'll deal with that in a bit. For now, let's go to our equation. 40 equals negative 5t squared plus 20t plus 25. Now remember, when you solve a quadratic equation, you have to bring everything to one side. So I'm going to bring 40 over, and when I do that, it becomes minus 40. So now 0 equals negative 5t squared plus 20t minus 15. And now once again, I'm going to solve this quadratic equation by factoring. So I'm going to factor out the negative 5 because it's still possible. So t squared minus 4t. But this time, negative 15 divided by negative 5 is positive 3. So now I need two numbers that multiply to positive 3 and add up to negative 4. So those two numbers are both going to be negative, and it's going to be negative 3 and negative 1. So that your solutions are positive 3 and positive 1. So if I go back to my sketch here, at 1 second and at 3 seconds, the ball is above 40 meters. But the question is asking me for how long is the ball over a height of 40 meters. So from 1 to 3 seconds, 1 to 3 seconds, that's a 2-second total. So our therefore statement will be, therefore, the ball is over 40 meters for 2 seconds. You can also add from 1 second to 3 seconds if you would like. Just make sure you read the question carefully, because sometimes I can ask you, at what time is the height 40 meters, or how long is the ball over 40 meters, that kind of thing. So just read carefully. So for this one, I gave you the height, which is the dependent variable, and then you just had to solve the quadratic equation. So in all of these questions, there are no new skills that you are applying. You just have to know what you're being asked to find. Let's go to the last one for this scenario. What is the maximum height of the ball, and after how many seconds does the football reach its maximum height? The word maximum should make you think of vertex right away. Now, you have options here. You can complete the square from your standard form if you'd like, but I already know my zeros. From over here, I know that my zeros are 5 and negative 1. And yes, negative 1 didn't make sense for question B, but it was still an x-intercept. So if I know my zeros, I can actually just average the zeros to get my vertex quickly. But again, you could have completed the square and that would have been perfectly fine. But I'm just going to use the more efficient method here. So 5 plus negative 1 divided by 2. 5 plus negative 1 is 4, and when we divide that by 2, we get 2. So that is the time. So maybe instead of xv, we should actually put t, because t is acting like our x coordinate. So that means at 2 seconds, the maximum height occurred. Now to actually find the height, let's plug in 2 for t. So negative 5 2 squared plus 20 times 2 plus 25. And then you can plug that into your calculator, or you can use BEDMAS here. So remember, exponents come first. So 2 squared is 4. Then we can do all of our multiplication. So negative 5 times 4 is negative 20. 20 times 2 is 40. And then plus the 25 at the end. And then you should get 45 meters. So therefore, the max height of 45 meters occurs after 2 seconds. So here, the key word was the word maximum, and that told you find the vertex, and you can use two different methods, whatever you prefer. So these projectile questions are very, very common. So asking about the initial height is the y-intercept. Asking about when something hits the ground or that base level, those are your zeros. Asking for a maximum is your vertex. Or you can be asked about the height, and then you just solve the quadratic equation. I can also give you a certain time and say, at 2 seconds, what is the height of the ball? And in that case, you just replace t with 2 and then plug it into your calculator or do some BEDMAS. Now, let's move away from projectile and try something new. So, the area of a rectangular slab can be modeled by the equation a equals x squared minus 3x minus 14. What values of x make the area equal to 40 centimeters squared? So we don't actually know what x represents. It doesn't necessarily represent a length or a width. It is just a value. So we are given the area, and that area is 40. So let's replace A with 40. And when we do that, we once again have a quadratic equation. And when you have a quadratic equation and you're solving for that independent variable, which in this case is x, we have to bring everything to one side, so that one side is equal to 0, and then solve for x. So when I bring 40 over, it's going to be minus 40. So I have 0 equals x squared minus 3x minus 54 when I collect those like terms. And again, we're going to factor. So I need a product of negative 54 and a sum of negative 3. And this is a simple trinomial, so I'm going to jump to my brackets. But if it weren't, I would do decomposition. You can also do decomposition here, though. It's just a bit more time consuming. So here our magic numbers are negative 9 and positive 6. So make sure you are careful with your signs. And now set your brackets equal to 0 and solve for x. So x equals 9 or x equals negative 6. Now, normally I would cut away that negative 6, but they didn't actually tell me that x represented a length or width, so I'm just going to present both options. Therefore, when x is 9 or negative 6, the area is 40 centimeters square. And there we go. The Sipapu Natural Bridge is in Utah. Its parabolic shape can be modeled by the equation h equals negative 0.04x squared plus 3.28x, where h is the height in meters and x is the distance from the base. How high up is it? So, them asking how high up is it is asking you for that maximum height, which is the vertex. Now in this scenario, you're given your standard form. So you can either find your zeros and average them, or you can complete the square and find your vertex that way. The choice is totally yours. So I'm going to do it both ways, and then you can choose what makes you happier. So if you are choosing to average the zeros, then first thing we must do is set h equal to 0. And when I set h equal to 0, I'm also going to start factoring, and I'm going to factor out an x. And you know what? I'm also going to test it out and see if I can factor out a 0.04, which I can. So I'm going to factor out negative 0.04x, and then I'm left with x minus, and when I do 3.28 divided by negative 0.04, I get negative 82. And now if I solve for my zeros, this one, when I set it equal to 0 and I divide both sides by negative 0.04, I get 0 for one x-intercept and then positive 82 for the other. So when I average them and I add 0 and 82 and divide it by 2, I get 41. So the vertex occurs when x equals 41, so at a horizontal distance of 41 meters. But I need to know the actual height. So let's go ahead and replace x with 41, and then we can jump to our calculator and plug it in to actually get the maximum height. And when we do that and we plug it in, we get h equals 67.24 meters. So that is your averaging method if you prefer that one. And it's not a bad idea to average the zeros here because it was a quick factoring method. It was a quick common factor and I got my zeros quite fast. If it were a regular standard form where there was a constant at the end, I'd probably jump automatically to completing the square, but again, the choice is yours. I will show the completing method as well. So completing the square. So here we don't have to set h equal to anything. Step 1, factor out that a value, and you're left with x squared minus 82x, and then you can write plus 0 at the end if you want that constant there. Now, I'm going to take that 82, or the negative 82, I'm going to divide it by 2 to get 41, and then I'm going to square 41, and I get 1,681, which I'm going to add and subtract to my bracket. Now the negative version, I don't need it, so I'm going to multiply it by negative 0.04 to kick it out of the bracket. So then I have x squared minus 82x plus 1681 in the bracket, and then negative times negative is positive, and when I multiply them, I get that 67.24. And then I can finish off that perfect square trinomial. The square root of x squared is x. I see subtraction for the middle term, and the square root of 1681 is 41. So then I get the same vertex as with averaging the zeros, which is 41, 67.24. And I have to pick the maximum height, which is 67.24. So I can write my therefore statement. Therefore, the height is 67.24 meters. And that's it for this one. They only wanted the maximum height. Let's try the next one. Another common type of quadratic scenario is a profit example. So in this one, the profit made from selling fidget spinners can be modeled by the equation P equals negative 0.2x squared plus 2.4x minus 2.2, where P represents the profit in thousands, and I'm going to highlight that because that is important, and X represents the number of fidget spinners produced in thousands. So any number you get, whether it's profit or number of spinners, you're going to have to multiply it by 1,000 to get the real one. So for the first question, they're asking us what is the maximum profit. When you see the word maximum or minimum, you should be thinking about the vertex. Now in this scenario, again, you have the option to try to factor this and then average your zeros or complete the square. For this scenario, I personally would jump to completing the square because I see standard form and I don't feel like dealing with those decimals for factoring. So I'm going to start off by factoring out the negative 0.2 so that I'm left with x squared, and then be careful, you are going to have minus 12x here and then minus 2.2. Now we can take that negative 12, divide it by 2 to get negative 6, and then square it to get 36. Now we're going to add and subtract 36. And then I don't need the negative 36, so I'm going to kick it out by multiplying it by negative 0.2. And when I do that, I get a positive number, and it's positive 7.2. And now we can finish this off. I factor my perfect square trinomial. The square root of x squared is x. I see subtraction, and the square root of 36 is 6. And then 7.2 minus 2.2 is 5. So my vertex is positive 6, 5. And in that vertex, 6 represents x, and the profit P is 5. But remember that it told us that the profit was in thousands and the number of spinners was in thousands. So we have to remember to multiply these numbers by 1,000 so that the maximum profit is actually $5,000. So therefore, the max profit is $5,000. And how many fidget spinners must be sold to reach the maximum profit? It's not 6, it is 6,000. Now, let's move away from the vertex and let's look at C. How many fidget spinners must be sold to break even? When you see the word break even, you have to familiarize yourself with what it means. It means that your profit is equal to 0. So you're not making money, but you're also not losing money. So if we're looking for the break even point, we're going to set our profit P equal to 0. So negative 0.2 x squared plus 4x minus 2.2. And because we set P equal to 0, we're solving for the x-intercepts here. Now, you do have two options. You can set P equal to 0 in your standard form and then factor and solve for your x-intercepts, which might be safer because it's the original equation that was given to you. But you can also take the vertex form that you just found and solve by isolation. And I'm going to show you both methods, and then you can choose whichever one makes you happier. So if I choose my factoring method, I am going to factor out this negative 0.2. And then that way I'm going to have a nice simple trinomial. Now I need two numbers that multiply to 11, but add up to negative 12. And those two numbers will both be negative. It's going to be negative 11 and negative 1, so that your x-intercepts are positive 11 and positive 1. That means you need 1,000 or 11,000 spinners to be sold. Therefore, you need to sell 1,000 or 11,000 spinners to break even. Now, let's say you didn't feel like factoring and maybe you wanted to solve by isolation and you wanted to use that vertex form. Here's your second option. Set p equal to 0 in your vertex form. And now I'm just going to isolate for that bracket squared. So I'm going to bring the 5 to the other side. It will become negative. Now I'm going to divide both sides by that negative 0.2. And when I do that, I get 25 equals x minus 6 squared. And now we're almost there. We just have to square root both sides. And it's important to remember that you get 5 equals x minus 6, but also negative 5 equals x minus 6. And now I can just bring the 6 over in each scenario. So 5 plus 6 is 11, and negative 5 plus 6 is positive 1. So exact same solutions as the factoring method, but you have two options. You can solve by isolation from vertex form, or you can solve by factoring from standard form. And there it is. Let's try our last one. How many fidget spinners need to be sold to make a profit more than $1,800? Now, we first have to take this profit, and we can't just take this profit and put it in for P, because we know that the profit P is in thousands. So our actual value for the variable is 1.8. You're taking that 1,800 and you're dividing it by 1,000 to get the actual variable. So I'm going to set P equal to 1.8. And again, you have the option here to sub it into your standard form or into your vertex form. Either way is perfectly fine. So I'm just going to do it from standard form just so that we can work on our factoring skills a bit more. So I'm going to bring the 1.8 over because that's super important for the factoring method. And when you do bring it over, it's going to be negative. Now we have negative 0.2x squared plus 2.4x minus 4. I'm going to factor out the negative 0.2, and I get x squared minus 12x plus 20. And now we can factor our simple trinomial. So what two numbers multiply to positive 20 but add up to negative 12? Both of our numbers are going to be negative again, and they're going to be negative 10 and negative 2. So when you set your brackets equal to 0 and solve for x, you get positive 10 and positive 2, which doesn't mean 2 or 10 spinners, it means 2,000 or 10,000 fidget spinners. So therefore, you need to sell between 2,000 and 10,000 spinners to make a profit more than $1,800. And again, you could have done isolation as well using the exact same steps we did in question C. And there it is. So in all of these scenarios, you are given the equation. You just have to recognize if you are going to solve for the vertex by completing the square or averaging the zeros, solve for the zeros by factoring, find the y-intercept, which is just there in standard form, or you just have to find a random independent variable where I gave you profit or I gave you height or whatever it could have been. So make sure you know how to read the question carefully, and then you should already have the quadratic skills to find those key properties from all the different forms.